Okay, so some of you guys have already drawn your picture. If you need help drawing your picture, I will do that with you. Okay, so an airplane is traveling north, and I like to put this on my grid. So this is north, east, south, west. Okay, and it's traveling north at 280 miles an hour. And feel free if you want to use different colors, you can do that just because that'll make them easier to see. That's perfectly fine. So here's my airplane. And I'm going to label that with its speed of 280 miles per hour. And then I'm just going to label that with my little A vector. Okay, so traveling north at 280 miles per hour. Now, I also have a 38 mile an hour crosswind that's flowing in the direction north, 60 degrees east. Right? So for north 60 degrees east, I'm going to start going north, and then I'm going to adjust 60 degrees to the east. Okay, so I'm going to, again, estimate where that's going to be. I'll say it's about here. And then, do you guys remember in the video they said, like, they'll draw that a little bit smaller? Don't worry about it if you forgot to do that. Okay, and that's going to be 38. And that's going to be our wind. Okay, so what we need to find is the true velocity of the airplane. And we want that as a vector expressed in component form and in terms of I and j. So first, let's recap what the true velocity is. Okay, so the true velocity can be found by adding the airplane vector and the wind vector. Okay, so the true velocity is going to be the velocity of the plane in still air, which is our airplane vector, plus the velocity of the wind. Okay, so to find that, I'm going to have to find the vector for each one. So first I'll start with the velocity of the plane. So for the airplane, to find the horizontal component, I need the magnitude times the cosine of theta. Okay, and Tate, what is going to be our theta value for my airplane? Okay, good. How do you know? Okay, so if it's going north, right, this is our angle. You start at 0, and you would go up to my airplane vector here. So starting at 0 and going up to my airplane vector, this is going to be a 90-degree angle. Okay, and then I'll have 280 times the sine of 90. Okay, and just remember that comes from the magnitude times the cosine of theta and the magnitude times the sine of theta that we wrote down on our other side. And then we're going to calculate. So at 90 degrees, George, what's the cosine at 90 degrees?
0.
Okay, good. So when I multiply this by 0, I'm going to get 0. And then the sine at 90 degrees is what? 1. So my airplane vector is 0, 280. Okay, and then if I want to express that in terms of I and j, it would simply be, 280j. Good. Okay, that's just for the airplane. Now I'm going to do the same thing for the wind. Okay, so for the wind, I found this from going 60 degrees which it said north 60 degrees east. So my theta value, Sydney, do you think you know what your theta value is going to be for this?
No.
Okay, so to find theta, where do you always want to start? Yeah, you're always going to start at 0, right? So I have this vector here. I'm going to start at 0. This is what I'm trying to find for theta. But I don't have that part. I have the top portion. I know that this is 60.
So it'd be 30.
Exactly. So if this is 60, your theta value is going to be 30 degrees. So I'm going to use that for the wind. Okay, so for the wind, the magnitude is 38. Cosine of 30 degrees, 38. Sine of 30 degrees. Okay, and this is an exact value, so you can go ahead and use your root 3 over 2 and your 1/2. And then if you just want to put it into decimal form, that's okay too. In the directions it says just you can round any decimals to the hundredths place. So you could think of this as 19 root 3, 19. Okay, or it'll be 32.91, 19. Okay, and then if I wanted to write that in terms of I and J, I could do 32.91I plus 19J. Okay, so remember, what we're trying to find is the true velocity. So to find the true velocity, we're going to add these together. And we call our true velocity vector V. Okay, so the true velocity is going to be the airplane vector plus the wind. And if we just add those together, do you think that's okay? Or do you want me to write out like the 0 plus 32.91? Okay, so when you're adding, you are doing the 0 plus the 32.91, which will just be 32.91. And then for the wind, you're going to do the 280 plus 19. And so if you guys want to write that part out, go ahead. So the 280 plus 19 is going to be what? 299. Okay, so this will be 32.91I plus 299J. And what was it that we just found?
True velocity.
Yes, okay, so we found the true velocity. Okay, it says then find the true speed. So the true speed, if we look back on our first page, we highlighted it. The true speed is going to be what?
A squared plus b squared squared root.
Yeah, which is called, the magnitude, right? Okay, so the true speed is going to be the magnitude. Okay, so it's going to be the square root of 32.91 squared plus 299 squared. Okay, and then, or you could use the 19 root 3 there. Okay, so that's going to be our true speed. Now for this one, it doesn't ask us to find the direction, so we can actually stop there. Our next example will ask us to find the direction, so that's definitely something we're going to use the tangent of theta for. Okay, so you start part A.